Algebra 2, Chapter 3, Section 1, Solving Equations. First, let's start with review. The equivalent operations that we can use to help us solve equations we covered in Chapter 1, Section 4. Equations can be solved using these operations. There were three main categories we talked about: adding or subtracting the same number on both sides of an equation, multiplying or dividing both sides by the same non-zero number, and replacing any expression on either side of the equation by an equivalent expression. Let's do some practice. Let's solve this equation. 7 plus 3p equals 1 plus 5p. So we'll remember the strategy we talked about before. We need to try to get p on one side of the equation. Let's start by subtracting 1 from both sides of the equation. 7 minus 1 plus 3p is 5p. 7 minus 1 is 6. Now let's subtract 3p on both sides, and we get 5p minus 3p. Remember, we can subtract the coefficient and have an equivalent expression. So we can replace this expression with 2p. Dividing both sides by 2 is not 0, that's allowed, is 3 equals p, so our final answer is p is equal to 3, is the solution to this equation. Let's go on to a more complicated example. Let's solve this equation. Here we need to remember minus 2 is being multiplied by this. We do not start with 1 minus 2. That would not be the order of operations. PEMDAS, please excuse my dear Aunt Sally. First we need to do this operation, then multiply, then we would subtract. So to undo the operations, we have to go in the backwards order in order to solve for x. These operations have to do with the order you would evaluate if you had a value for x. So when we solve, we're going to be going backwards. So the first thing we need to do is distribute. Well, we could move the 1 over. Would be the first thing we could do. Undo the subtraction or addition here. Minus 2, 3 minus x. By subtracting 1 from both sides, we get 10 minus 1 is 9 plus 5x. Now, we need to distribute the minus 2 in order to get the x out of here such that we can solve. So minus 2 times 3 is minus 6. Minus 2 times x is 2x. And now we have an equation similar to what we had last time. Let's add 6 this time. Adding 6, we get, that goes away, 9 plus 6 is 15. Subtracting 5x, 2 minus 5 is minus 3. So I combine two steps here to save a little time. Once we get the hang of this, we can combine some steps to save time. So here we have minus 3x is 15. Dividing by minus 3 gives us minus 5 is x. And that'll be our final answer. So we can put a box around it. Now we can always check. Maybe this problem is complicated enough that we'd like to be sure that we got the right answer. Let's put minus 5 into the original equation and check. So now we're going to evaluate, so we'll do things exactly in this order. And be sure that when you substitute, you put a parenthesis so you don't get confused. If you write minus minus, that might be confusing, or you might forget to write the second minus. Substituting in negative 5. So first, what's inside the parentheses? Minus a minus 5 is plus, so this is 3 plus 5, which is 8. We can do this multiplication now. 5 times negative 5 is negative 25. 2 times 8 is 16. 10 minus 25 is minus 15. 1 minus 16 is minus 15. Minus 15 equals minus 15. That's a true equation, so check. Now let's solve an equation where we have either more than one variable and we're wanting to solve for just one of them. Or maybe these are constants. Typically, we would write this would probably be a variable, this would probably be a constant. But we can solve for x whether they vary or are constant, either way. So to solve for x, it's just as if these were numbers. Need to undo the operations. First subtracting z from both sides. We have n minus z. And now dividing by 2, n minus z divided by 2. That's the answer. Let's do an even more complicated one with abstract number. So here a is an abstract number, some constant number that we're going to solve for w. First thing we need to do to solve for w is to combine these two terms. Remember, we can add the coefficients. We can still add the coefficients even though one of them is abstract. Now if we add 5 to both sides of the equation, we have all the stuff with a w on one side and everything without w on the other. Now divide by a plus 3 on both sides, and we have this. Now we have to be careful. We are assuming here that a is not negative 3. If a is negative 3, then there's no solution at that particular value, because we'll end up with a division by 0 when trying to solve. Think about the original equation. If a was negative 3, we would end up with this going away. You'd have negative 3w plus 3w, and you'd be left with a false equation. Minus 5 is 12. So the answer is all of this stuff. W is this expression, except that a can't ever be negative 3. If a is negative 3, we get no solution. That helps us annotate that. What about situations where we might need to use a non-equivalent operation? And this can happen. So we may actually use a non-equivalent operation to solve an equation, as long as the potential solutions that we come up with to this non-equivalent equation after we use the non-equivalent operation are checked against the original. So we have to check. Okay? Have to check. A solution that is added, which was not an original solution to the equation, is called an extraneous solution. Just think of extra. Some people call them spurious solutions. It's a solution that's not a solution to the original equation, but comes up after because we added this non-equivalent operation. Some examples of non-equivalent operations that we might use but may add extraneous solutions are multiplying or dividing by a variable that might be 0, or raising both sides of an equation to an even power. Both of these operations are not equivalent. We may end up creating new solutions that are not solutions to the original. Let's do some examples. Solve the square root of x is negative 2. Well, if we think about it, one operation we could do to both sides to help us solve would be to square both sides. Because if we square both sides, the square root will go away. We'd be left with an equation x equals 4. But we're not going to box this yet, because we remember from the previous slide, raising to an even power is not an equivalent operation. Let's check our potential solution. So this could be an extraneous solution. The square root of 4 equals 2. So does 2 equal minus 2? No. So x equals 4 is an extraneous solution, which means there are no, I'm going to put in parentheses, real numbered, which we can assume for now, solutions. Solve the following equation. So we're going to need to use our algebraic fraction things we've talked about last time. However, when we're just dealing with an equation, we can simplify fractions without having to multiply numerator and denominator by multiplying the denominators. So let's start with x minus 2. If I multiply this equation on both sides by the number x minus 2, you'd end up with x minus 2 times 1 over x minus 2 equals x minus 2 times this whole thing, 3 over x plus 2 minus 6x over x minus 2, x plus 2. Brackets here are just a way of saying we're a parenthesis that's really big. It just helps us keep track of how they group together. Oops, I'd lost a parenthesis here. So we use a little parentheses in here and these big brackets in the ends to help us remember this is all happening at once. Okay, now we can distribute. Here we just multiply the numerator in and we get x minus 2 divided by x minus 2, which is just 1. Those cancel, which is what we were trying to do. So we have 1 equals, here we have x minus 2 times 3 when we distribute over x plus 2. And when we distribute into here, we have minus 6x, x minus 2 over x minus 2, x plus 2, and the x minus 2's cancel. So we're left with 1 equals 3x minus 2 over x plus 2 minus 6x over x plus 2. And now we have the same denominator. We can just subtract the numerators. 1 equals, and we can distribute the 3 in. So let's go ahead and do the distributing to 3. We have 3x minus 6, and then we have minus 6x over x plus 2. And now we can again multiply the equation on both sides by x plus 2, the denominator on the right, to get x plus 2 equals x plus 2 times all of this, and x plus 2 times all of this. The x plus 2's will cancel. We'll be left with just the numerator. The numerator, we can combine the coefficients of the x's, so we'd have minus 3x minus 6. Now, rearranging the equation, subtracting 2 and adding 3x, I'll get x plus 3x is minus 6 minus 2, which is 4x equals minus 8. And we have x equals minus 2. But we're not done. We did something that is not equivalent twice. We multiplied an equation by a number which might be 0. X minus 2 and x plus 2. So let's check. If we plug minus 2 into this equation, we'll have 1 over minus 2 equals 3 over minus 2 plus 2. Uh-oh, I already see a problem. Minus 2 plus 2 is 0. When we do minus 2 plus 2, we'll have division by 0, which is undefined. So this is not a solution. It's extraneous. Since that was the only possible solution we came up with, this equation has no solution. So we can, remember my shorthand, we can write this null set, which means there's no solutions. There's nothing in our set of solutions. Or you can write no solution. Now let's try solving this equation. The cube root of x is minus 8. So again, if we take and raise both sides to the third power, we get x, because by definition, if we cube a cube root, we get back what was in it. X equals, and 8 to the third power is 512. So minus 8 times minus 8 times minus 8. Remember this, just cubing means multiplying the number by itself 3 times. Okay, so that we'll have a negative, 3 negatives, minus 512. Now, we can go back and check. The cube root of minus 512 is minus 8. So we have an answer that's correct. But raising to an odd power is an equivalent operation. We don't actually need to check. If it's an even power, it's not. Odd power it is. Haha, more algebraic fractions. Here we can multiply both sides by each denominator. So multiplying the equation by 3 plus x and 6 minus x results in canceling each of these denominators, which is kind of a technique that lends to a thing called cross-multiplying, I'm sure we've all heard of. So if we cross-multiply is a fast way of solving this kind of equation. is equivalent to multiplying both sides of the equation by each of these denominators. Remember, multiplying by these denominators is not an equivalent operation. It's not equivalent because each of these might be 0. Okay, so let's go ahead and write our cross multiplication. Do our distribution. Combine like terms, or get the x's on one side and the not x's on the other. Combining the like terms, we have minus 7x is 3. Now we need to divide both sides by minus 7, and we have x is 3 over minus 7, which we can write as minus 7 thirds. Sorry, minus 3 sevenths. Cut the back. I accidentally reciprocated the fraction. So we can always make a silly mistake. Now we need to go back and think, does this make these denominators 0 and thus invalidate our solution? Well, only minus 3 or 6 would do that. So this is a solution. X is minus 3 sevenths.